Brendan Escamilla, and this is my midpoint summary project for special education 6327 Introduction to Educational and Psychological Measurement. So, in Module 1, we began with a strong focus on definitions. This was necessary to review for those who have not taken or seen statistics in a while, such as myself. It was particularly helpful for me. We dove specifically into the differences between the population parameters as seen in the picture on your screen and the sample statistics symbols that we will be encountering as an educational diagnostician or a special education teacher who will have to sometimes read and interpret evaluation results. Another important thing that was also mentioned in Module 1 was the Gaussian curve, or otherwise known as the standard normal distribution. We specifically examined its symmetrical bell-shaped and the predictable nature of data within X number of standard deviations from the mean. This is how we interpret a lot of our results in the educational field, and it is super important for us to know what the normal distribution is and what it represents. When not looking at data that takes the typical shape of a bell curve or does not have symmetrical data, I'm sorry, we may have to interpret it. And as explained in our lecture videos, if the majority of the data points fall below the mean of our data, we see the data using the Gaussian curve. We notice that the distribution takes a different shape. If a majority or the median of our data falls below the mean, our data is positively skewed as seen in the image on your screen here on the left. If the majority or the median of the data falls above the mean, then our data will be negatively skewed and take the shape of this one, of the negative skewed data. If the mean, median, and mode are the same in our data set, then our data is symmetrical, which is described by the normal distribution. So as we shift into Module 2, we began to learn about the measurement scales. We learned about the four types. We had the ratio, interval, ordinal, and nominal scales. Understanding their hierarchical nature and the types of analysis that is appropriate for each. Understanding the differences between the scales are as follows. An example of a nominal scale is when you are comparing people or things with numbers, but don't but those numbers don't necessarily have any meaning other than that they're an identifier, such as a school lunch number, or for us, our PeopleSoft ID number. It's just something to identify us. An example of an ordinal measurement scale could be the degree of youngness in a person, such as a toddler, adolescent, adult, etc. These classifications provide us with some details about the person and what we could be expecting to see. For example, if we're going to be working with a baby, a teenager, or an adult. The interval measurement scale and the ratio measurement scale are similar, aside from a true zero. For instance, when we start thinking about the days in the year, we have 365 days in a year. But we don't start the new year at January 0, we start at January 1st. Hence, there's an interval measurement scale because there is no true zero. There's not a real zero to work with when we're talking about the days of the year. The ratio measurement scale is more in depth. It measures of temperature are very good examples for me to understand what a ratio scale and how a ratio scale is different from an interval scale. So talking in simpler terms, Fahrenheit is in an interval scale. So being 0 degrees Fahrenheit doesn't mean there's not any temperature to measure. It just simply means it's 0 degrees Fahrenheit. Kelvin, on the other hand, has an absolute zero because having 0 Kelvin means that there is an absence of molecular motion, which is a little complex, but I found it helpful to understand what a ratio measurement scale was. Age is also another good measurement scale example, because being 0 years old means that you haven't lived at all. So apart from the measurement scales, there are 11 different types of various scale scores. They are the raw scale score, the percentage mastery scale, the linear transformation scale, also known as standard scores, the percentile derived linear scale, percentage rank scale, normalized scale, aka um, normalized standard scores, age equivalent scores, grade equivalent scores, IQ scores, EQ and AQ scores, and lastly, normative versus non normative derived scales. And I'm only going to talk about three of these scales, because not all of them are relevant to the purpose of our class. So the raw score scale is pretty self-explanatory. It is simply just a score without any adjustments, like the number of questions answered correctly. Interpretations of raw scores can be difficult. The percentage mastery scale is an absolute type of judgment of mastery on a specific subject matter. So for example, an 80% means mastery level of whatever subject is being tested. These are useful when testing for a highly specific purpose. They are common these are common in classrooms, but they can be overgeneralized outside of uh, this context. Lastly, linear transformations or standard scores are used to interpret and compare raw scores. This is preferred because the interval property of measurement is not disturbed. Standard scores, while they are useful for comparison, they face several issues. They're often misinterpreted. Their meaning is highly context dependent, and they usually reflect socioeconomic factors more than innate ability to due to disparities in test preparation. All tests inherently have measurement error. This is inevitable, which can lead to unreliable scores, especially for young children or subsections. Additionally, tests can contain subtle cultural biases. High stakes of these scores can cause some serious test anxiety and stress as well. So shifting onto module 3, we continue to dive into different statistical terms like the standard deviation and the variance. Standard deviation is a measure of how spread out the numbers are. Variance is the average of the squared differences from the mean. Moving on, the classical true score theory, or CTT, is the foundation of the methods used to evaluate the reliability and validity of tests and surveys. So you get this score by adding the true score and the error score, and this is seen from this screenshot from our lecture PowerPoints. The most general and most commonly used type of norms is the national norms, appropriate to the educational age level for which the test is designed for. This is a Woodcock language proficiency battery test that is a decoding measure which measures one's reading ability. This subset also measures the ability to identify letter forms or words. For this subset, data was gathered from 6,359 subjects in over 1,000 geographically diverse U.S. communities. There were 705 preschoolers aged 2 to 5 years old, 3,245 K through 12 students, 916 college or university students, and 1,493 non-schooled adults aged 14 to 90 years old and not enrolled in secondary or college institutions. This visual representation of how different test forms form X and Y can be equated to ensure fairness and comparability of scores, and is a helpful illustration for this concept. It also helps us understand that linking is an important component of equating. Today, we will use item response theory, which was developed in the 1970s, but before that, we used classical test theory in order to evaluate and place students. This moves us right along to the next part of my presentation, where equating typically happens during the test development and involves multiple forms of the same construct being designed and tested with the same or similar population or sample. Linking is simply pairing two scores with no explanation or reasoning behind why they are paired. An example of this is SAT and ACT scores. I believe that this is a good summary of what was covered in modules 1 through 4. Um, Thank you so much for your time, and I apologize for going over by a couple of minutes. Thank you.